we are very happy to be here with you guys. So this is to our Energy Municipal and Efficient Electrification series for municipalities. So today we are talking about inflating your savings, optimizing blower system in wastewater treatment plant, and we have four guest speakers. Stephen Dixon, Christian Tam, Andrea Dwight, and Melody Johnson. I will let them present themselves just after presenting the agenda. So for today, we're talking. We will have a small introduction, and then we'll talk about the blower technology and sizing, sizing system, sizing parameters. And after that, we'll talk about optimizing for efficiency through a total system approach. And then we will have a small case study, municipal wastewater treatment plan training with LAS. So, Stephen, I will let you present yourself, and then we can
Sure.
let
Actually,
other
just back up,
presenters.
stay on the overview slide there for a second, please, Mintu. So what Andrea is going to do is she's going to kind of take a overall system approach, looking at the systems from end to end, not just changing a blower, but how is the blower influenced by the downstream conditions, and how do we optimize the whole system, including the use of measurement and metering and controls. So it's going to look at as an entire system. So on the next slide, why are we doing this? Well, if we take a look at on the next slide, Mintu, the amount of energy that typically is used in these systems is significant, right? So they're a major energy consuming system. And they can have significant impact on the way these plants actually operate, depending on whether they're a Class B or Class A, meaning with respect to the electricity pricing in Ontario, they're Class A, then again, these systems can have significant impact on their Class A 5 top peaks in that sense. So there can be an opportunity to maybe optimize pricing that way through the global adjustment. And our blower and systems are found throughout these plants, right? In aeration, grid chambers, channel blowers, and aerobic digesters. These systems, if not optimized, I think are a lost opportunity. So, Andrea, you're going to sort of stand back from this one and start off by sort of looking at the idea of how we optimize. So I'm going to flip it over to you, and I'll be in the session throughout, maybe adding a few comments here and there, supporting Andrea. And then Kristen at the end will actually talk to us about where we've gone and done a treasure hunt, like a collaborative search for opportunities, and applied some of the results. And blowers were part of that too. So over to you, Andrea.
Oh, thanks, Stephen. My name is Andrea Dwight from Blue Sky Energy Engineering, and I'm happy to be here today to talk about blower systems, as they are such a significant load on wastewater treatment plants. Mintu, could you go to the next slide, please? So as previously mentioned, we want to take a holistic approach and look at operational efficiency, not just from an energy standpoint, but an operations lens as well today. And we don't have much time, but we're going to do an overview of the systems before and after blowers, along with controls and some measurement techniques that hopefully will give you some opportunities to save energy and costs. Mintu? First, we're going to take a look at some of the blower technologies and recognizing that aeration in bioreactors is probably your biggest blowers. There are a number of different ways that you aerate. We're not going to talk about mechanical aerators today, but we will be discussing a little bit about centrifugal blowers and turbo blowers. There are various ways that they can be controlled. Some are more efficient than others. And if you are considering in the near future replacing your blowers, and you have an opportunity to do so, there are a few things you need to keep in mind. Slide. So if you're replacing your blowers, thinking you're probably, especially in your bioreactors, you're going to probably be looking at turbo blowers because they're so efficient, but centrifugal blowers still have their place. The centrifugal blowers have a wide range of pressure and flow capacities. They allow for fairly decent turn down ratios and workhorses, but you have to keep them on their sweet spot on their fan curve. So you have to be aware of that. Turbo blowers have many advantages, including the fact that they have a very small footprint. They come in an integrated package that are pretty easy to install. But you do have to make some decisions around which kind of bearings you wish to use, magnetic or airfoil. And there's some circumstances that they don't run that well. So they don't like being turned off and on a whole heck of a lot. So depending on your situation, you'll need to take a look at what's best for you. Slide. So along with this whole design piece, you will need to not only know what your capacity is, which is really important, but also your minimum, not only your maximum air demand, but your minimum air demand. And for example, in a bioreactor, that's dependent on tank surface area. And we'll discuss a couple of examples in a minute of why this is important. For digester aeration, it's based on tank volume. And of course, you also have to be able to understand oxygen requirements for the biological demand, which is different for every plant. So organic loadings to the bioreactors. And just a couple other points. Keep in mind that, and we'll speak to this from a design perspective, if you're overhauling your system, you may want to take a look at installing an anoxic zone, or perhaps if you're not ready to replace your blowers, think about installing a jockey blower, which is a smaller blower that basically can be added along with your existing blowers that you can size so it's perfectly right sized in the sweet spot that you're operating today. And that may be a cost-effective way of saving energy and being able to operate effectively.
Andrea, I just want to, there is a question, and on that slide, I just want to reinforce what you just said about the jockey blower. A lot of times people consider looking at new blowers or new devices and then putting speed control on those things, which can be quite expensive, whereas that jockey blower can be a very cost-effective solution and actually a fairly reliable one too from that point of view. There was a question here from Vladimir. Will you be covering replacement of mechanical aerators with pump systems that entrap air?
Not in this presentation because we have relatively little amount of time, but I'd be happy to discuss it afterwards.
Yeah. So actually, at the end of the session, Vladimir, Megan will talk about coaching sessions that are available, sort of some follow-up support. So, and Andrea could then sort of talk to you one-on-one about those things. So I'll let Megan speak to that one. Thanks. Continue, Andrea, please.
Yeah, that's great. Thank you. So next slide. One example we had, which speaks to the design conditions and capacities, was a plant we went into a few years ago. It had 3 bioreactors, and the influent loadings were much lower than their design. And in this case, their air demand for mixing was much higher than even the organic loading. And we were able to recommend that they shut off one of their bioreactors, and that actually significantly reduced the load on the blowers. And although their system was running really well, they were using more energy than they needed. And just consider that a 50 kilowatt savings can be significant in the pocketbook. It could save you up to $45,000 in electricity costs, and it'll likely help you with global adjustment costs for the next year coming.
So actually, Andrea, on that point, what I always like to keep in mind is that 1 kilowatt off the 5 top peaks is worth anywhere from $300 to $500, minimum $300. So 50 kilowatts off all 5 top peaks could be worth $15,000. So that increases that opportunity significantly.
Yeah, that's great, Stephen. Another example we had when it came to right sizing and design of the systems and understanding airflows was a plant we went into with 2 grit blowers that had 2 grit chambers that had aerated systems, and there were 2 blowers running into these 2 grit chambers. And we decided that we go back to first principles and calculate how much air was required in each of these grit chambers, and we found that they were running 1 extra blower. and they were able to shut that off and save a significant amount of money by just understanding the actual design flow rate properly and being able to match their system needs to that flow. And it's something they didn't pick up because the grid chambers were working properly. So it was simply a savings measure. Next one, please. So we're going to go from talking about the technologies to talking a little bit about some consideration of upstream equipment, downstream equipment, what things you can measure and monitor, and how you might want to try and use controls to save energy. Again, this is a holistic approach because the blowers need to work hand in hand with a whole bunch of different systems. So I'm going to throw this over to Melody, and she's going to take us through upstream equipment and some measuring and metering discussions.
All right, thanks, Andrea. So looking at upstream process equipment, this is upstream of your bioreactors. The first place, if your facility has primary clarifiers, that's a great location to look at optimizing the performance of the primary clarifiers, and the amount of organic material that you can remove through the primary clarification process can drastically reduce the organic loadings in your downstream bioreactors. And that in turn reduces the oxygen demand and the amount of air that you need to push into those reactors. So some approaches that can be useful is carefully controlling sludge blankets to avoid any washout of solids and to avoid any solubilization of organic contaminants that are in particulate form when they come into your facility. Also looking at coagulant and potentially polymer addition to have a chemically enhanced primary treatment. Just being careful there not to overdose and create some downstream nutrient deficient conditions in your bioreactors. The next is looking at return activated sludge pumping. You want to have enough RAS pumping to control the sludge blanket in your secondary clarifier, but if you overpump RAS, you can actually also increase oxygen demand in your bioreactors. So balancing what the clarifiers need versus what the bioreactors need can help to reduce oxygen demands. Next slide. In addition to the upstream treatment process equipment, there's also the influent itself. And in municipalities that have large industrial contributors or that have industries that want to increase their organic discharge rates to the collection system, all of that is going to impact the oxygen demand at the wastewater treatment plant. That affects your ongoing operational costs and energy use, obviously. You need to push more air into bioreactors. But it can also affect the required sizing of your aeration system equipment, since they're generally based on achieving sufficient oxygenation to address peak loading conditions. So that's definitely something that needs to be taken into consideration, what the impact will be on the aeration system. In addition to the oxygen demand, additional organic loadings mean more sludge, which means if you have aerobic digesters, more aeration demand in those digesters, as well as potentially just needing larger tanks. So all of these can increase your operational cost. It can move forward your timing for plant expansion. And so there's always the possibility of pursuing cost recovery in the form of some type of surcharge agreement. Next slide. So now we'll get into some measurement and metering. First to deal with the energy itself. Then we'll look at some process measurement and metering, airflow meters, dissolved oxygen, COD and equivalent BOD as well, to control the aeration system and reduce the energy use. So I'll hand it back to Andrea to discuss the current sensors and power meters.
Thanks, Melody. So if you have a new turbo blower, or if you have a new you have a VFD on your motors, on your centrifugal blower, you'll be measuring already energy use. And if you can't see it, you might have to ask your team to put it on your SCADA system, or get it tracked on your data historian. But if you don't have a method of measuring energy, you really need one. And there's a couple ways you can go. One is, of course, getting a power meter installed, and they're a little more expensive, but they're very accurate. And power meters can measure a number of different things, including power, quality, sag, etc. So that can be very helpful if you're having issues. But another way to go, which is cost effective, is just buying current sensors. There's a few companies now in Ontario that sell these that are wireless. And so the data goes up to the cloud and can be downloaded, and you just clamp them onto the 3 different phases. And unfortunately, they're not quite as accurate as power meters, but they give you great information. They're easy to install, and you'll be able to trend how your blowers are operating as you do improvements, and hopefully be able to validate savings. Next slide. Back to you.
Andrew, I'm just going to reinforce what you said about the current sensors. You're right, they're not a revenue grade meter, but with proper setup, they can be almost as good at a small fraction of the cost. So don't get caught up sometimes in the need to go after revenue grade meters for sub-meters for doing this kind of monitoring.
Okay. Moving on to the airflow meters, there's 2 main types of devices available. There's volumetric flow or mass flow. Volumetric flow obviously will measure the volume of gas that is passing through at any given moment. But because the volume of a gas varies with temperature and pressure, you would also need to have that information to be able to really know how much air, how much oxygen you're providing to your system. The other is a mass flow type, and that measures the actual mass of the gas that goes through at any given moment. Both of these can be used in municipal wastewater treatment plants for feedback-based DO control. Monitoring your airflow rates can also identify potential issues, like a broken header perhaps, or air loss in the system. The flow rate is often expressed as standard cubic feet per minute, which looks like a volumetric flow, but it's actually defined for standard temperature and pressure, so that the air will have a fixed density. So it's really just converting a mass into a standard volume. And those flow meters should be calibrated at least once per year. Oftentimes, in our experience, they're the kinds of flow meters that aren't always calibrated routinely at municipal plants. Usually the focus is on the liquid flow meters and the gas. Next slide. Next is dissolved oxygen. So many treatment facilities will use DO to control the airflow rates to their bioreactors. The DO, oops, we've lost the other, it's back again. The DO sensors should be calibrated frequently. So definitely recommend looking at what the manufacturer recommends and ensuring that you keep up with that. Also doing periodic spot checks with handheld DO sensors, just to make sure that your sensor isn't drifting. The other thing to keep in mind is that location is important. The highest oxygen demands in a bioreactor are at the head of the tank, and then the lowest oxygen demands are at the end of the tank. Generally, if you only have one DO meter, you would want to put that about 2/3 to 3/4 of the way along the aeration tank. And that will help to avoid a situation where you're over or under aerating by measuring a DO concentration that isn't really representative of the typical conditions in the tank. Next slide. There are also some additional devices out there that can give you an idea of real-time organic loadings coming to your facility. So everyone knows the BOD test takes 5 days to complete. It's useful in hindsight, but not in the moment. Some facilities have started using chemical oxygen demand analyzers, online analyzers that directly measure the COD of the influent wastewater. To use these, you need to develop a relationship between the BOD and COD of the wastewater coming to your facility, but they can give you a heads up if there's an increase in influent loadings that perhaps you weren't anticipating, or have feed forward control of your aeration system. Another option that is being used that is actually quite interesting is the Sentry system. It uses biomass as a sensor. The biomass generates an electrical current as it consumes contaminants in the wastewater, and it gives a good representation of highly biodegradable contaminants coming in. And again, you need to develop a site-specific baseline for each facility, but it can give you a heads up that you might need to increase your air or that you can decrease it depending on the influent characteristics at any given time. Next slide. The next is chasing that global adjustment, those peaks, and reducing your energy use during those critical times. So the little orange note there says it would likely require 10 to 15 reduction events to ensure that you hit the 5 Ontario peaks. And one effective way of trying to reduce your energy use during those peak events is to shut off aeration. So that is actually a possibility. You can do that for several hours at a time, 4 hours, even up to 8 hours. We would only recommend that if your plant is operating in a very stable manner. You have consistent effluent quality, your mixed liquor concentration is where you want it to be, and the mixed liquor is settling well. If you have any kind of process upset going on, likely not a good idea. When you turn the air off, all of the solids in the bioreactor will start to settle. So you won't need to have that return activated sludge pumping going. You would want to shut off waste sludge pumping as well. There is the potential that you would have some odor when you start that back up, similar to a aerobic digester after decanting. And then for facilities that have aerobic digesters, shutting off the aeration to those digesters, trying to hit those peaks is also an option. And it can reduce your peak consumption during those periods as well. So with a 50 kilowatt motor, if you hit all 5 peaks, you would be looking at a $15,000 savings. I'm going to hand it back to Andrea.
Yeah, thank you. Let's talk about downstream equipment a little bit. So we want to start with the air distribution systems or headers that you have downstream of your blowers. When they get first installed in a new plant, they're usually done in a very optimized fashion that reduces friction by minimizing elbows, etc. But if you've ever had an expansion in your plant, some of this distribution piping may not be as efficient as others, and they might be creating unbalanced loading or constrictions. It's worthwhile going and taking a look to see if any of that downstream header piping can be optimized. And you want to make sure that it's done well so that you can effectively control the splits between your plants. That being said, one of the things that I really think is important that sometimes gets overlooked is fixing small leaks. So the picture here is a small temporary tubing outside of a blower, which isn't very large, but even a 1/4 inch orifice hole through a flange leak can lose 75 CFM. And that doesn't seem like much when you're running 7,500 CFM, but 1% over a year is still a fairly hefty energy cost. And it's better to fix them when you see them.
Andrea, I just did a quick calculation on that 75 CFM. You're probably looking at, it could be anywhere from $5,000 to $15,000 a year.
That's excellent to know. Thanks, Stephen. The next piece after the header is, of course, valving, and you're going to have manual valves and automatic valves, and you need to make sure that your automatic valves are maintained and have been exercised through the full range of their open to close area. And the reason is that if they're not opening fully, that will also create pressure drops, which will increase the loads on your blowers. And you want to try and avoid using your manual valves as much as possible. They're there for balancing and isolation, but try to find a way not to use them to reduce flow. Always try and use your motors, either add VFDs if you don't have them, or use your turbo blower to dial down the speeds. And this is simply due to the fan laws that tell you that, that your brake horsepower varies with the speed of the motor by a factor of 3, which is significant. So you always want to try and reduce flow and control flow at the motor instead of using downstream valving. Next slide. This is an example of a plant we were in a couple of months ago, and this is a typical air header. It's going to 2 bioreactors. And you can see there are 2 manual valves there. And to give you some background, this plant has a turbo blower, and the turbo blower has a large amount of turn down ratio and range. But yet both of these valves are slightly closed. So one is halfway closed and one is a third closed. And that's sort of a red flag that perhaps this plant is using these valves not just to balance the air, but to also reduce the air to the aeration system. So they're losing money from an energy perspective by doing it this way. So we're working with them right now to make sure that they can still balance their system, but try and get one of those valves fully open and reduce the airflow using their turbo blower controls. Next slide. Next element after the valves are diffusers. And of course, in your aeration system, you've got a couple different kinds. Ceramic membranes are being used much more readily, and they need to be maintained at least once a year. And along with the aeration tanks, the channel blowers, aerobic digester blowers, the way that you see if there's plugging is to look at the surface of the tanks to see if you see any anomalies in the bubbles or mixing coming to the surface. So if you see any changes to that surface, that may indicate you've got plugging and you've got to deal with it. And again, plugging just leads to, poor air distribution, but also higher pressure drops, which create loads on your motor. Next slide. So we're now going to talk about the blower controls. And, obviously our objective is to satisfy the oxygen demand of the process. And we're going to be talking primarily around the aeration tanks, because those are your biggest blowers, your bioreactors. And you're trying to do that, you're trying to satisfy the oxygen demand at the lowest possible cost. So we're going to go through a few different control scenarios that you might want to consider that can optimize the efficiency of your blower system. Next slide. So in general, just so we're all on the same page, the mechanisms of how most of the blowers are controlled are through physically controlled through variable frequency drives or through inlet vane throttling or guide vanes. And obviously, controlling your motor speed is the most energy efficient method. And so you need to try and move to that if you're not doing it now. However, how much air you need is a tiered system based on your DO requirements, but with your DO requirements alter the position of your control valves, which then change the system pressure when they're opened or closed. And so there are different ways that we can control the speed of your blowers through either measuring system pressure, flow control, and we're going to talk a little bit about mostly open valve control as well. Next slide. So mostly open valve control, we need to understand or remember that with common header, the whole system has the same pressure drop across all the valves. And the more open a valve is, the lower the pressure drop is, which also creates a lower load on your motor. So if you can have at least one, if you have a multi-valve system, automatic valve, and you can at least program it so that one valve is always mostly or 100% open, then the whole system will have a much lower pressure drop across the valves, and you're going to save energy at your motor. So it is a little bit of programming required to do it that way, but it could save you up to 10% in efficiency. Next slide. So the next one we're going to talk about is ORP control, and I'm going to send this over to Melody to discuss.
Sure. So usually plants control their blowers using dissolved oxygen. And dissolved oxygen will tell you how much oxygen is dissolved in your bioreactor or in your digester, but it doesn't necessarily explain what is happening with the bugs themselves, what type of oxidation they may or may not be doing. Oxidation reduction potential, or ORP, can give you some insight as to what the bugs are actually doing in the tank. And that's separate from the measured dissolved oxygen concentration. So for most bioreactors, ORP is going to be plus 100 millivolts to say 250. That's sort of the range where you would get BOD degradation as well as nitrification. If you want to run a system with on-off aeration, which is something that SBRs are often do to reduce energy use, ORP can tell you when you switch from being in the BOD degradation to denitrification mode. And then that can give you some insight as to when to turn the blower back on to avoid anaerobic conditions. So denitrification takes place from -50 to +50. If you're in that range, you can keep the blower off. It also helps with control of denitrification systems. If you have an anoxic zone and a mixed liquor return, you can reduce your mixed liquor return to target that ORP. Another option is if you have an aerobic digester. Typically, aerobic digesters are operated with a lot more air than they necessarily need from a biological perspective. So if your ORP and your digester is plus 200, you can usually pull back that aeration to target an ORP of somewhere between 50 to 100, which would be much more effective from an energy conservation perspective.
So other opportunities, a few things to think about when you're controlling your blowers. Then if you have multiple blowers, the sequencing really counts. And it's really important to relook at your fan curves, because often we're not operating at capacity. So how can we stage our blower sequencing to be most efficient? And typically motors don't like being run below 50%. They're less efficient as our blowers. And oftentimes we have very, very large blowers. So as Stephen had mentioned, installing a jockey blower, leaving all of the existing blowers in place and installing a jockey blower to run at a sweet spot with your current flow rates may be a really, really good alternative. And it also provides an intermediate size blower range when you have to add a new one or add more than one blower at a time. Also, recognize that when you put two blowers on, you're not getting double the airflow rate for double the energy use, because the second blower is blowing into a pressurized system and there are efficiency losses due to that. So it's often good to try and run primarily with one as much as you can, and then add a second one on top when you have to. We've already talked about adding an anoxic zone, because this reduces your oxygen requirement long term. That might be very, very helpful. And just a couple of points regarding the frequency of changes. As you get into more sophisticated blower control, just be a bit careful about the process lag and not causing your equipment to go into loops by changing the set points too quickly. So be aware of that. You don't really want your blowers to be turned on and off many times, in an hour. So if you can get a blower running and run it continuously, that's always the best way. Otherwise, there's more wear and tear than you need. Next slide. Just one maintenance consideration is really making sure that everything's clean. If you have a turbo blower, you probably are already dealing with this because the inlet air ducts have to be kept clean. But with other systems, centrifugal blowers, multi-stage ones, they can chug and chug and chug, and you don't realize because the system's running that you're actually losing money. So making sure your airflow filters for your inlet air are kept clean, so the pressure drop isn't increased. And of course, the loads on your motor would increase. And I guess just to summarize, you want to look at not just the blower technology, but the upstream equipment and downstream equipment, as well as how you control it to make sure that you're getting the most energy savings you can and fitting the amount of blown air to the need. And with that, I'm going to send it over to Christian. Next slide.
Thank you, Andrea. Oh no, just stay on the first, on the other slide, please. Right. Well, the name is Christian. That has been said already. Just a little bit about LAS and what we do with municipalities. I know we didn't get a chance to introduce ourselves. We are a municipal non-for-profit organization that work with municipalities. We develop our primary aim is to develop programs and services for municipalities, and 3 things to do to help them reduce cost, to build capacity, and to become more efficient. The wastewater treatment plant energy workshop and treasure hunt is one of such programs that we've developed for municipalities. And just so you know, we work with the Association of Municipalities of Ontario. So that's who we are. I have been in this seat for the last 7 years now. Prior to this, I was working with a municipality outside of London as a municipal energy manager. Next slide, please. Sure. So we've done this training with municipalities. One of the big municipalities I can mention here is York Region that has participated in our energy workshop and treasure hunt for operators. The benefits of what we do is we bring the training to your plant. So as a municipality, it saves your operators, from traveling to a different place. So travel costs, right there. And also the workshop has incentives that IESO gives for the workshop that we offer. But like I said, York Region has been part of it before, and other smaller municipalities. And I want to talk about a municipality in Northern Ontario that participated with a population of less than 50,000, and a treatment plant that was built in the 60s and recently upgraded in 2013. Daily treatment of 20,000 cubic meter hydraulic capacity, 81,000. It's a secondary treatment plant. And that's where we did the energy workshop and treasure hunt. It is interesting because, Stephen, you remember we did this training just at the time when we were coming out of COVID. So we couldn't go on site and we delivered it virtually. But you'll be surprised whether virtually or on site, energy savings opportunities are still there to be identified. It was a creative way of doing it, and it did work in terms of the savings that we identified. Next slide, please. So treasure hunt and the search for savings. Where are the savings? In a wastewater treatment plant, there are 3 major areas where savings are hidden. And basically that's the pumps. Andrea has spoken very well regarding blowers. That's another a strategic area where savings are hidden. And of course your HVAC system. With your pumps upgrades, big thing to look at your pump sequencing controls. And when it comes to the aeration, of course, the dissolved oxygen sensors, pressure sensors, filtration maintenance, and the turbo blowers that we've spoken about, so eloquently well. Then, of course, heating source. What kind of heating source? Is it a natural gas heating source? Is it electricity, what kind of heating source is what goes on within the plant? How are we maximizing biogas? Biogas is methane, to be specific. It's a byproduct of what goes on in a wastewater treatment plant. So how is that being maximized in terms of heating? Or even could it be solar walls? If you're talking about net zero planning, are we looking at a solar air heaters? That could be utilized. So
Actually,
for this,
Christian, on that note, I just jump in. One of the
Sure,
best applications of a solar wall that I've ever seen, based on a case study. I haven't been to the site, but was actually in a northern wastewater treatment plant where you needed a large amount of ventilation, where the northern Ontario, your sun in the winter is lower in the sky. There's a good potential there for a solar wall. So it's sometimes some unusual things come out of these.
Exactly. And certainly, we are in kind of an era of net zero emission reduction. We've got a national target of net zero emission by 2050. So as a municipality or organization, if you can incorporate some of these interventions at your wastewater treatment plant, is for the broader good. You're doing the right thing, you're helping save energy, and at the same time, you're helping reducing emissions. Right, next slide, please. So where did we find the savings? Stephen said it so well, a jockey blower. Jockey blower, it's a great way. He said it very well. I can't even say it anymore more than that. But then instead of you keep the jockey blowers, a smaller option, but the existing blowers are still there, and you maximize savings instead of bringing in working on a bigger existing blower and bringing in VFDs. That will be the cost implications will be huge. A jockey blower replacement could be one area to look at. So that was one of the savings that we found there. In terms of air leaks, the rooftop units, duct and insulation repairs were one of the savings opportunities that was also identified. And Andrea said it. We did the math. For a small air leak, 15,000 or 15K per annum. That's a significant amount of money. And to fix that leak wouldn't cost you that much. But once you do it, you're going to see the savings. And what else?
Christian, I think one of the things that we often realize, and when we do these treasure hunts, and I'll speak in the next slide a little bit about what we do, but basically we realize there's the process things, which we've talked a lot about today, and those are important. But for me, the hidden thing, Andrea, is often it's the other stuff, the supporting systems, and we obviously you're focusing on those big systems, but a lot of opportunity lies in those existing auxiliary systems, and that's the lighting and the rooftop units and things like that. Right. So don't neglect those things in the big picture. They may actually contribute quite nicely.
That is very true, and I've seen it being very, very consistent with most municipalities that have wastewater treatment plants. Talking about LED lighting upgrades, we as LAS we have another program that offers lighting upgrades for municipalities. It's a turnkey service that we do offer, and we've had countless municipalities. The recent one that comes into mind is Orangeville, that has participated in our lighting upgrade at their wastewater pollution center. And I know Collingwood has done it, Blue Mountain has done it, Kenora, and the list just goes on. So those lighting upgrade is kind of an interesting thing because it's the low-hanging fruit. It's a smaller things, but then it's going to save you a big amount of money. And as I said earlier, if you have biogas on site, are you just flaring it away, or you are maximizing it in terms of heating, space heating for your facility? So these are some of the things that some of the hidden treasure that we found on this wastewater treatment plant. And what were the lessons? Oh, sorry, I was changing the slide here. Next slide, please. I changed and didn't move. What were some of the lessons that we learned? Training is such a powerful tool that impacts the bottom line of an organization, sadly often overlooked. And the question I always pose when I'm talking about training or what we do as LAS is, what is your return on investment? For investing a small amount of money to train your operators on site, we come to site and do the training, compared to the energy savings that you're going to identify. And when you move on to the savings, the tens of thousands that you're going to save and see it in your bottom line. So those are some of the lessons that we learned, and we've always been learning from energy savings.
Christian, can I
Go
jump
ahead.
in on that one too?
Please go ahead,
And
Stephen.
I love your quote there, Christian. That's like, that quote. I love it. If you want to go fast, go alone. If you want to go far, go together. And going far meaning great energy savings. So
Exactly.
these treasure hunts are really a collaborative effort. We call them a training session, and they are classified as that. But ultimately, there's a bit of training and there's a lot of sharing, right? And the sharing is both ways, right? So what we want to do is, and really the way we set the training up is to actually almost trigger or catalyze the flow of knowledge and information, ideas from the people who operate the plants. It's like we have some energy knowledge. You have a huge amount of knowledge about how your plants operate. We're going to bring those two things together and we're going to deliver some significant results. So many of the ideas that come out of this don't come from us as the energy people. They come from the folks in the plant. And our job is to put the numbers to and evolve those ideas into something that can be taken forward to fruition. So sorry to interrupt you, but I just wanted to speak to the process. It's a collaborative process.
Yeah, no, you said it very well. And I appreciate you, interrupting, because time just coming from one source monologue, it becomes boring. But if you have a dialogue, you're able to get your message across, and that's what you just did. The lesson learned here is the power of the collective. And you'll be surprised. You sit and you work in our silos. Every organization does that. Municipalities do it. But when we come together as a team and we are on site and we have the operators on site and we are there as facilitators, you'll be amazed the savings that we identified. And it has been very consistent from wastewater treatment plants to arenas to any other kind of energy treasure hunts that we've done. We've identified tons of savings, and those were not identified by us, but just that hands-on interactive exercise with the arena operators or with the operators at the plant. We identify those savings. So that takes me to the good old saying that if you want to go fast, you go alone, but if you want to go far, you go together. And that speaks of teamwork and coming together to learn. The power of the collective is so strong, and we can make such a great impact. So if you're a municipality online and you're interested, please give us a call. Whatever we've done here is just 1 hour. It's kind of drinking from a hose pipe. Give us a call. We will come on site. We'll have a training with you. The IESO makes incentives available for this. There is no reason why you shouldn't do a training for your operators. They need it. It will help your organization. It will help your bottom line. Thank you.
Thanks, Christian.
So
Thanks,
I'm done
everybody.
from my side. Yeah.
Christian, I think it's a good transition because I wanted to talk about the one-on-one coaching. So as Christian mentioned, you have the opportunity to have a one-on-one coaching, specific to your wastewater plant, specific to your building, and talk to the experts. So feel free to contact us. I'll put the link in the chat after. And also, there is many the resources in the IESO website that you can find, some fact sheets, some older webinars as well, MNV templates. And also, don't forget, we have another webinar in 2 weeks that will talk about getting your energy project done. So we're waiting for all of you, and it will talk about tool and strategy for implementing your energy project. So we are waiting. We want to have a big number. Thanks everyone. We have talked about a lot of strategies and energy savings opportunities in wastewater plants. So feel free to reach Andrea, please, and Melody, Stephen, and Christian. Thanks everybody. Oh, also I saw that Megan put the link in the chat, so you can use the link to reach out and to have the one-on-one coaching.
Actually, the only thing I'll add on.
Oh, right.
Sorry. Go ahead, Christian. Okay,
no, I
was
just going to say,
say,
do we have any questions from them? I think maybe we still have some time, 3 minutes. If there are any questions from the audience.
On the coaching piece, recognizing that a few people online might be from outside of Ontario, that coaching is available from folks within Ontario. Although I'm sure folks from outside Ontario can access some of the online resources on the website there too. So
sure.
I've been following the chat there. I don't see any.
If you have any questions.
No hands up.
I think we are good. They are good. We are good.
Well, Andrea, that was great. It was a rough start for you, and I know what it feels like to be in that seat. So thank you for your patience. But I think it's worked out well. It's flowed really nicely. So thanks everybody.
Bye.
Thank you.
Okay, thank you all,
Thanks.
and
Thanks
for
for
coming.
everybody's time.
Bye. Okay. Bye-bye.
Bye.